Margaret was 84, legally blind from macular degeneration for 6 years. She told me, quietly, that every evening at dusk, 3 Victorian children appeared in her living room and played silently on the carpet. She knew they were not real. She was not frightened. She was not confused. Her cognition was intact. Her MRI was clean. Her psychiatric history was empty. She simply wanted to know who they were and why they had chosen her. I have been a physician for 19 years. This is one of the cases I cannot explain. Margaret's case is not rare. It is, in fact, one of the most underreported phenomena in modern ophthalmology. The condition has a name: Charles Bonnet Syndrome. It was first described in 1760 by the Swiss naturalist Charles Bonnet, who documented the experiences of his 89-year-old grandfather, Charles Lullin. Lullin, nearly blind from bilateral cataracts, reported seeing men, women, birds, carriages, buildings, tapestries, and scaffolding, all in vivid detail, all silent, all recognized by him as unreal. Bonnet published the observations in his 1760 work, Essai Analytique sur les Facultés de l'Homme. The case sat largely forgotten for nearly 2 centuries. The syndrome was not formally named in the medical literature until the Swiss neurologist Georges de Morsier reintroduced it in 1936. Even then, it was treated as a curiosity. What changed was the epidemiology. As populations aged and age-related macular degeneration became the leading cause of visual impairment in the developed world, clinicians began to notice something. The hallucinations were everywhere. A 2022 systematic review and meta-analysis by Subhi and colleagues, published in Annals of Eye Science, pooled data across 24 studies and found a prevalence of 19.7% among low vision patients, roughly 1 in 5. Earlier work by Teunisse and colleagues in the Lancet in 1996 had already placed the figure between 11 and 15% in ophthalmology clinic populations. The hallucinations follow a particular grammar. They are exclusively visual, never auditory, never tactile, never olfactory. They range from unformed geometric patterns, lattices and flashes of light, to fully formed figures, people in period clothing, animals, landscapes, miniature adults, fantastical creatures. The images can be in color or monochrome, static or animated, lasting seconds or, in rare cases, hours. Patients retain full insight. They know what they are seeing is not there. There is no delusion, no paranoia, no cognitive decline. What is more striking is what does not appear in these patients' charts. No psychosis, no dementia, no delirium, no drug effect. The neurological workup is clean. The psychiatric interview is unremarkable. And yet, the visions are relentless, specific, and often deeply strange. Most patients never report them. A 2014 paper by Cox and F. Vicha in the British Journal of Ophthalmology found that fewer than half of sufferers disclose symptoms to their physician. They are afraid, understandably, that to describe the visions is to invite a diagnosis they do not have. The standard neurological explanation for Charles Bonnet Syndrome is elegant and, for most cases, sufficient. It is called the deafferentation hypothesis, or the release phenomenon. The argument runs as follows. The visual cortex, specifically the ventral occipital lobe, including V4 for color, the fusiform face area for faces, the parahippocampal place area for buildings and landscapes, does not merely receive data from the retina. It actively predicts, constructs, and interprets visual input. When retinal input collapses, as it does in advanced macular degeneration, glaucoma, or diabetic retinopathy, those cortical regions do not fall silent. They become hyperexcitable. Deprived of their normal afferent signal, they begin to generate activity spontaneously. The content of the hallucinations reflects the specialized region that is firing. Faces from fusiform cortex, landscapes from parahippocampal cortex, geometric patterns from early visual areas, V1 and V2. The mechanism is pharmacologically plausible. The loss of retinal drive reduces GABergic inhibitory tone in the occipital cortex, and cholinergic and serotonergic modulation, particularly at 5-HT2A receptors, becomes permissive for spontaneous pattern generation. This is the same broad family of mechanisms implicated in phantom limb phenomena. The brain, deprived of peripheral input, fills the silence with its own signal. The evidence for this model is concrete. Dominic Ifeach and colleagues at King's College London published a landmark functional MRI study in Nature Neuroscience in 1998, scanning CBS patients during active hallucinations. They observed increased activity in the ventral occipital lobe that correlated precisely with the content of what patients reported seeing. When patients hallucinated colored objects, V4 activated. When they saw faces, the fusiform face area activated. The mapping was specific, repeatable, and neuroanatomically coherent. The mainstream position, articulated by researchers such as Oliver Sacks in Hallucinations in 2012, and by Anil Seth in his work on predictive processing, is that Charles Bonnet Syndrome is not mysterious at all. It is, in Seth's framing, a particularly vivid demonstration that all perception is a controlled hallucination, a top-down prediction constrained by sensory input. Remove the sensory constraint, and the prediction runs free. Michael Schur-Mayer has used similar examples to argue that there is nothing spooky here, only neurology behaving lawfully. This is a strong argument. It accounts for the prevalence. It accounts for the specificity. It accounts for the preserved insight, because higher-order frontal regions responsible for reality monitoring remain intact and can correctly flag the imagery as internally generated. For most patients, this explanation closes the case. For most patients, not for all of them. The deafferentation model accounts for the mechanism of hallucination. It does not account for the content, and it is the content, in a specific subset of cases, that makes experienced neuro-ophthalmologists pause. Consider the phenomenology documented in F. F. Weich's 2005 Review in Progress in Retinal and Eye Research. A substantial minority of patients report highly stereotyped recurring figures. The same specific individual, in the same period clothing, returning across months or years. Others report elaborate scenes with narrative, internal logic. A procession of monks, a woman in a 19th century dress, tending a garden, miniature figures interacting with one another in coherent ways. The question is not whether a deafferented cortex can generate spontaneous activity. The question is why that activity so consistently organizes itself into culturally specific, narratively coherent, persistently recurring scenes. Consider, too, the anatomical anomalies. There are published cases of Charles Bonnet phenomena arising after lesions along the posterior visual pathway, occipital infarcts, lateral geniculate lesions, optic tract damage, where retinal function is intact but cortical input is disrupted. Colmel reported a series in the Journal of Neurology, Neurosurgery, and Psychiatry in 1985 describing complex visual hallucinations following occipital stroke in patients with normal eyes. The release model survives this, but only if extended considerably. Then there is Margaret. I went back to her chart. Her MRI, as I said, was clean. No occipital infarct, no cortical lesion, no white matter disease beyond what is expected at her age. Her ophthalmology workup confirmed bilateral dry macular degeneration with central scotomas. Her mini-mental state was 29 out of 30. Her visions, the 3 Victorian children, had appeared for the first time 11 months after her visual acuity dropped below 20/200. They always appeared at the same time of day. They always wore the same clothing. She described the fabric, a specific green pinafore on the smallest girl, in detail that did not waver across 6 follow-up visits. She had no Victorian ancestry she was aware of, no particular interest in the period, no photographs in the house matching the imagery. For the visions to occur as she described them, several cognitive faculties had to be simultaneously intact and simultaneously engaged. Object recognition, face processing, scene construction, temporal continuity across episodes, memory consolidation, because the children returned identical across months, reality monitoring, because she always knew they were not there, and something else, harder to name, a kind of authorship, or the lack of it. Margaret did not feel she was generating the children. She felt she was receiving them. This is the part the deafferentation model handles least well. It explains why the cortex fires. It does not explain why it fires this and not something else. Why a specific child in a specific pinafore rather than noise. Why the same scene rather than a new one. Why narrative rather than static pattern. Fichet himself, in a 2007 paper in Current Opinion in Neurology, acknowledged the gap. The release hypothesis, he wrote, describes the permissive condition for hallucination. It does not describe the generative one. Something is selecting the content, and we do not know what. What would it take to answer this properly? To move from describing Charles Bonnet Syndrome to understanding it? There are researchers working on it. Dominic F. Fichet's group at the Institute of Psychiatry, Psychology, and Neuroscience at King's College London has maintained a CBS research program for over 2 decades, combining functional imaging, phenomenological interviews, and longitudinal follow-up. The Macular Society in the United Kingdom funds the Esme's Umbrella Initiative, which has built one of the largest CBS patient registries in the world. In the Netherlands, the group around Van Dijk and colleagues has extended the phenomenological mapping. The work is slow because the instrumentation is blunt. Functional MRI can tell us that V4 activates when a patient sees a colored bird. It cannot tell us why that bird and not another. EEG can tell us that alpha rhythms over occipital cortex are disrupted in CBS. It cannot tell us what is being rendered in the disruption. We can measure the canvas. We cannot yet read what is being painted on it. What would we need? We would need single neuron or small population recording at depth in human visual cortex during active hallucination, something currently possible only in rare intraoperative contexts, such as the work done in epilepsy patients with stereo EEG implants. We would need decoding algorithms capable of reconstructing visual content from cortical activity, of the kind pioneered by Jack Gallant's lab at Berkeley, and extended recently by groups using diffusion models to reconstruct images from fMRI. We would need those algorithms applied not to seen images, but to hallucinated ones in blind patients in real time. None of this is science fiction. All of it is, at present, beyond routine clinical deployment. And there is a deeper instrumentation problem underneath the technical one. We measure heart rate. We measure respiration. We measure blood pressure, oxygen saturation, temperature. These are the 4 vital signs. They tell us the body is alive. They do not tell us there is someone inside it. Consciousness, the experience of being a subject, the thing Margaret was doing when she watched 3 children who were not there, is the signal we infer but do not instrument. I think of it as the 5th vital, the one we take for granted because it usually accompanies the others, and the one we have no proper tool to measure when it behaves anomalously. Charles Bonnet Syndrome is one of the cleaner windows onto this problem. The patients are lucid, the cognition is intact, the hardware is documented, and still, the generative process that selects the content of their visions is opaque to every instrument we currently have. Margaret came back to the clinic in the spring. I had, by then, given her the diagnosis. I had explained the deafferentation hypothesis. I had shown her Fiicchi's fMRI figures on my monitor and told her, honestly, that what she was experiencing was well documented, that she was not losing her mind, that roughly 1 in 5 people with her degree of vision loss saw something similar. She was relieved. Not surprised? She had suspected as much. She told me 2 things that afternoon that were not in my original notes. The first was that the children had begun to fade. Not disappear, fade. The smallest girl, the one in the green pinafore, was now translucent and appeared less often. Margaret described this with a kind of regret. She had grown used to them. The second was that her husband, dead 11 years, had never appeared. Not once. If her cortex was releasing stored imagery at random, she said, surely he would have come. He had not. She asked me why. I did not have an answer. I still do not. The deafferentation model is, I believe, substantially correct. It describes a real mechanism, supported by real imaging, in a real condition that affects millions of people, and is routinely missed by clinicians who do not think to ask. I am not proposing anything mystical. I am noting only that between the mechanism and the content, there is a gap, and that the gap is where the interesting work remains. Margaret sees children who are not there. She knows they are not there. And something in her, which we cannot locate and cannot measure, has chosen them, specifically, and keeps choosing them, night after night, in a green pinafore, on a carpet in a room she can barely see.